indeed enacted will be an important consideration for us. I'm going to walk through a bit just to frame the question about the research and the debate that has been going on, I think, for several years now at this point. As John mentioned, the Harvard, Boston Indicators, and UTIL report, I think, presents a pretty strong case for why two means of egress limit small and mid-scale apartment building development, and points to internationally, single stair access points are common and safe when combined with modern fire protection system. So the question that's raised is, can Massachusetts code be updated to unlock really a lot of undevelopable infill type sites, support family size units, and improve affordability without sacrificing safety? There's also research by the Pew Charitable Trusts and the National Fire Protection Association, which sort of frames the question as well. The NFPA had a single stair symposium that concluded any change must emerge from rigorous consensus-based code development. Safety issues such as egress failure, firefighter access, and construction limits require thorough study, according to that symposium. But the potential benefits for affordability and sustainability continue to be explored by NFPA. And really, as we were saying earlier, for us, it's not a matter of choosing between safety and housing, it's really achieving both. And to the extent that our code development system can be focused on this and really decide what makes sense. So with that, let me introduce Stephen Smith, who will discuss housing and design benefits, and Jennifer Hoyt, who will address fires and life safety considerations. Stephen is the executive director of the Center for Building in North America, a nonprofit he founded with the goal of doing research and advocacy about building codes and standards in the US and Canada. The organization is focused particularly on cost and quality of multifamily construction with an emphasis on global comparative research. Jen Hoyt is a professional engineer and a senior technical advisor at Code Red Consultants. Through her prior work at the Mass Department of Fire Safety and her continued involvement in code development, both in Massachusetts and nationally, she has advocated for consideration for both the fire service and public safety. And she is, by the way, a on-call volunteer firefighter with her hometown and a member of the Board of Fire Prevention Regulations. So we thought we'd start with Stephen, and I do think I saw him join us.
Yep.
And then Jen will follow up, and then we'll open up for questions. We got a few questions we've sort of teed up, but then certainly want to hear from everyone who's been able to attend. So with that, assuming Stephen is around, if you want to jump right in on your presentation.
I am here. Am I sharing my screen?
Yes.
You are.
Okay.
Great. You were at the bottom of my list, so thank you. I appreciate you showing up.
So thanks for having me. My name is Stephen Smith. I'm coming to you from my own single exit building in New York City. It's 5 stories. New York City has a special code section, has had one since 1938 to allow up to 6 stories with a single exit, a true single exit building, no fire escape. Hopefully these buildings are safe because I'm living in one. My mother lives in one. My grandmother lives in one as well. So I will start. Why do building codes matter? There's been a lot of focus on housing affordability in the last couple decades. A lot of it has been focused on land use and zoning, which is very important, but ultimately you're really only playing with the 20-ish% of the development costs that are associated with the price of land. Most of the cost of development, though, is not in the land; it's in the actual structure in the building. What is actually built matters just as much as how much is built and where it is built for affordability. So, what some people call the YIMBY movement, Yes in My Backyard, has sort of turned, not given up its land use advocacy, but been more interested recently also in building codes and things that can affect the hard and soft costs beyond the land. So that's where this comes from. So there's a UK fire engineer named Jose Torero, who's the head of the engineering department, something at University College London, who somewhat provocatively says the fire problem has been solved, and now the question is about cost optimization. I think it goes a little far. However, for modern multifamily buildings, the fire problem has almost entirely been solved. It is fire deaths in new multifamily buildings built after the advent of sprinklers are extremely rare. Um, they are very rare compared to deaths in single family houses, both older ones and newer ones. And it raises the question of whether the cost of these buildings is actually harming life safety overall by pushing people into, single family houses, in particular older single family houses that not only have much higher rates of fire death, about 4 times the rate of fire death for a single family house built after 2000 compared to an apartment building built after 2000, and something like 6 times the rate of fire death for a single family house built before the year 2000, which of course is the majority of homes in America. Um, the United States has a very the United States and Canada have a very particular cost curve when it comes to housing. In much of the rest of the world, the economies of scale balance out the diseconomies of scale when we talk about different typologies. So a single family detached house costs about the same to build as a mid-rise multifamily building. This sounds a bit strange in America. There are lots of costs that are imposed on multifamily buildings that are not imposed on single family buildings. You might have an elevator, you'll have more intense egress and fire protection features. However, this will be balanced out by the fact that you only need one entrance, you only need one basement, you only need one roof. Um, but in the United States and Canada, these are not balanced out. The cost just rises as you go from single family to mid-rise multifamily. And if I had a high-rise multifamily on this chart, it would just be off into the stratosphere. So we've got a bit of a problem, which is our safest buildings and the ones that you know politically we've decided we want to build more of for land use considerations and where the demand is are the most expensive, and they're far more expensive than our typical construction in the United States of single family houses. So codes in the United States compared to those abroad have what I'll call a fear of heights. The taller, everywhere as you get taller, your code requirements start ramping up, but in the United States, they ramp up faster and harder than anywhere I've ever seen. So, the second stair is required at 4 stories in most of the US. In Europe, it definitely varies widely by country, but let's say about 16 stories, you get the second stair. Standpipe in the United States, 4 stories. Europe, typically a high rise, let's call it 8 stories. Stretcher elevator, 4 versus this varies in the United States, excuse me, in Europe, but around 8. Sprinklers, you typically don't find them in Europe unless it's or Asia, unless it's like a sort of true high-rise building, a skyscraper. In the United States, any height has sprinklers in a multifamily building, and if the model code bodies had their way, then they'd also be in single-family houses. And you can find this in lots of different things, not just the fire protection features. Um, Speaking specifically about the single stair height limit, if you look at single stair height limits around the world, you notice a pattern, which is the lower income the country, the lower the height limit. So you have, some extreme examples, Uganda, Pakistan, which require them at any height, essentially 2 stories. Um, and then on the other side, you can't see this because there's so many that it's so small, but you have some of the higher income countries, Switzerland, South Korea, have no single stair height limit. And then most of continental Europe, the height limits are really true skyscrapers. So, 80 meters, which is about 30 something maybe 20 something stories in Italy, 90 meters in Austria. Um, and then the outlier, though, returning back, is the United States. The IBC, limits you to 3 stories with a single stair. The city of Chicago actually limits you to 2 stories. NFPA's code is a little more lenient, not used that much, but it is used in Vermont and Georgia. Limits you to 4 stories. Puerto Rico limits you to 5. But the United States and Canada are the real outliers here. We are very strict about single stair relative to our level of wealth. So when it comes to building design, this is most important, probably only really relevant on small lots. Of course, in most of the world, a small lot building, and frankly, probably a lot of Massachusetts, is the dominant form of multifamily housing. We have, in the United States, for various code reasons, we have pushed our buildings to be larger and larger. Now we have these sort of 5/1 style buildings that, might fill half a block. But historically, and, both in the United States and currently abroad, most buildings are, on a small lot, maybe anywhere from 25 to 7,500 square feet. This is a picture of a building from Jersey City, across the river from Manhattan. Jersey City adopts the IBC, so it requires a second stair at anything above 3 stories. This is on a 25 by 100-foot lot, and you can see that this second stair, shaded in yellow, takes up about seven, and plus the corridor necessary to achieve the 1/3 diagonal separation distance. Although I've been told that this building actually might not meet code, and they might have approved it inappropriately, so that the numbers might actually be more stark than this. Takes up about 7% of the floor plate, and then you have some floor area that still needs to be built regardless. It's that shaded green area, but which is less efficient because it has to be in the hall rather than in the unit. Um, if you look at just the cost, the dollar cost of that, it's about 10% of total cost. Stairways tend to be more expensive than the rest of the building since they're very small enclosed spaces. Um, so in the world of hard costs, that's quite a big deal. 10% of total construction cost is enough to tank almost any project. Jersey City has very high rent, so this building penciled out and I believe is being built. But beyond the cost, you also have these sort of interior bedrooms which barely really have any window at all because you have to imagine that there's another building right next to it. So in addition to the cost, there's also a big quality hit to the housing. These are almost windowless bedrooms as a result. Next slide. Okay, so getting into the technical life safety issues, we have some challenges in the United States, which is that, abroad you typically get two options for a single stair building. Either you offer, access to aerial apparatus, trucks with ladders, to, maybe one floor, maybe one unit, maybe just a stairway, depends on the country. Or you have some sort of pressurization or ventilation system in the stairway. This poses two problems for the United States. One is that our fire departments generally do not rely or do not want to rely on aerial rescues. The equipment is perhaps not as well suited to it as that in Europe. Our codes do assume some sort of aerial firefighting, sort of ground-based aerial apparatus firefighting, but it's generally limited to suppression, not rescues. So that's a problem. The other problem is that this sort of a dirty little secret about high-rise buildings is that nobody puts much faith in the way that pressurization systems are built, required in high-rise buildings and built, which poses another problem. Our codes also tend to prioritize firefighter operational flexibility above all else. A lot of what happens in a building, whether someone lives or dies, really happens before the fire department shows up. But the way that we write codes and sort of do this consultation in America, we really place a heavy emphasis on firefighting operational flexibility. What is what did the data say here? Well, the data is not the best quality, but New York City does have over 4,000 of these buildings, including the one in the picture, which is the one that I'm coming to you from. And it is enough to look at the safety record. And what we found, I did a report with Pew Charitable Trust, is that there have been no deaths in single stair buildings that can be attributed to egress whatsoever. There have been a couple deaths in single stair buildings in New York City, but the people died in the unit, and there's no evidence that the smoke penetrated the stairway or any other units. The sample size is not enormous, but it is what we've got in the United States. There are also some single stair buildings in Seattle. Seattle has long allowed 6-story single stair buildings, and similarly, the records are pretty good in Seattle, and there's again been a death in one of the buildings, but it didn't have anything to do with egress. The other places in the United States that have long allowed single stair buildings above 3 stories are Georgia and Vermont, per their adoption of NFPA 101 in lieu of IBC Chapter 10, the egress chapter. Puerto Rico also modifies the IBC, historically allowed 6 stories, now I think allows 5. The data there, I wasn't able to find property level data to identify the single stair buildings, so I don't know for certain, but I will say there was never any controversy about this in those states or Puerto Rico before. Well, there's still no controversy about it, but there was never controversy about it, and no one even really thought much about it before the single stair discussion kicked up nationally a couple years ago. So a lot of advocates around the country have been very interested in changing this. Here's a map of cities, states that have passed or at least introduced legislation to at least study the issue. Some of them have gone so far to pass legislation to either pass legislation or through their normal code adoption process have actually modified their codes. Um, it is a lot of places. Building and fire officials have not been happy about it, but at the end of the day, codes are laws, and we do live in a democracy where lawmakers have some say in that. The IBC, the ICC International Code Council, which writes the IBC, has responded to this pressure. I think perhaps not totally happily or fully in consensus, but nevertheless, for the 2027 model code, something is working its way through that would raise the height limit to 4 stories to keep it roughly in line with what NFPA has allowed for since 1991. Again, to no controversy until now. And this will be voted on, I think, next year. There might be some modifications made here or there, but essentially it just raises the limit from 3 stories to 4 with a couple of other tightenings here and there, but they're kind of minor. So what's being proposed in Massachusetts compared to elsewhere in the country is very conservative. It is just a study. The truth is, in code development nowadays, a lot of the money that goes into it is from vendor interests. So, the timber industry paid for the very expensive testing that was needed to legalize mass timber. The sprinkler industry has long poured a lot of money into code development to get sprinklers in as many buildings as possible. You have other smaller interests that, sprinkle money around and get their thing. The National Association of Home Builders obviously spends a lot of money on code development. However, they focus this on the IRC. Multifamily interests are not very present or active in the code development process. But it also raises the question of why we're sort of letting vendors and special interests, spend money when money needs to be spent. So I think Massachusetts does something that a few other states have done, Minnesota and New York, and or at least the proposal is to allocate some money, I believe roughly $250,000, which is also actually about the cost of a stair, one single stair, to study this issue. And I think I think it would be great if there was more independent, government study of this. Unfortunately, the code development process largely, relies on volunteers. So unless governments are going to, put money into this, certainly the federal government is retrenching from this stuff. They were never that involved to begin with. It's going to have to come from states. So, that's why I support the bill. And I think I'm already over my time, so I will end it there. Thank you.
Thanks, Stephen. That was great. Appreciate it. Jen, I think you have a presentation you want to walk through for folks.
We have the floor, yes. Let's see. Can you see my screen?
Not yet.
Not yet.
Not
Okay.
yet.
Can you see it now?
Yes, Ken.
Okay. So that was a great presentation with a lot of information, and I just my role here is to try to offer some perspective and to kind of speak to some of the fire service's reasoning behind some of their opposition and their hesitancy in moving forward with a code change proposal that's not supported by studies that focus the fire service perspective. And so because there's not a lot of information and quantification of what the fire service is really concerned about, there isn't a whole lot of data available. And that's really kind of the point that I'm representing. So when we talk about these buildings, the primary goal is life safety and then property protection. And so with a single exit stair, you definitely reduce a level of redundancy that's been built into the codes for a long time. And so there's reasons that we have codes that are put in place, a lot of it is based off of historical fires and lessons that we've learned from tragedies in the past. And so when we move forward and make a change, looking at something that hasn't been fully experienced, it doesn't necessarily mean that it's doomed to fail. It just means that we need to do a little bit more research to make sure that we fully understand all the aspects before we just go ahead and change the code. So once we do and we change the code and these buildings are built, they're going to stay in perpetuity until they get replaced by something else. So thinking about this problem and building and fire safety in general, there's a general concept of evaluating life safety. So you have a required safe egress time, which is the time that it takes for somebody to recognize that there's a hazard, to start moving towards a safer situation, and to complete egress and to fully evacuate the building. So that takes a certain amount of time. Some of that can be measured and estimated based on walking speeds and the distances to an exit and the time available for a stair enclosure. But a lot of that is a bit more cognitive on whether the detection systems are working, how somebody responds to that, their mobility level, their cognitive ability to reason that it's a fire alarm and that it's serious and that they need to move towards the exits. And certain things will help increase the amount of available time, which is where the building codes come in. So they provide a set amount of available time for egress. So the construction of the building, the robustness of the stair enclosure, the speed of smoke detection, and the efficiency of the fire alarm system, adding sprinkler systems in that help reduce the heat that's being produced by a fire and kind of help to control it to a room of origin so that it doesn't spread beyond a certain level, compartmentation of the building to try to minimize smoke travel throughout the entire structure. So whatever we do to change our available safe egress time, that time needs to still encompass and exceed the time needed for people to evacuate the building. And so that's kind of the concepts that we're working with here. These are some historic fires in low-rise residential buildings, but you can kind of see the amount of ladders that are thrown. The picture on the right is actually from Boston. It's a historical Boston picture, and they're notorious for throwing a bunch of ladders to buildings. In some cases, it's for occupant evacuation, but in most cases, it's so that the firefighters that are showing up at a building and working in a building where the conditions are rapidly changing and degrading have an ability to safely egress. So while the codes primarily focus on fire and life safety, it's usually life safety for the building occupants itself, not necessarily for the firefighters that need to go and respond to these incidents. Talking about single exit stairs and that problem specifically, I don't have very good pictures of interior building operations. The one on the left is a training facility, and you can see that the hoses aren't charged, but they're on the stair. And so in a building where the fire department needs to enter and add water to a situation to try to get the fire under control, those hose lines are charged, and perhaps they don't need 5, perhaps they need 2, but you can already see if they're not laid in the right place, they start encroaching on the width of the stair. They create a trip hazard. So if you have regular occupants from the public that are trying to use those stairs at the same time as firefighters, there's going to be some issues. The picture on the right is actually the engineers in our office went and did a training day with a local fire department so that they could kind of understand some of the constraints that the fire service has when they're responding to buildings. So we put them in gear and had them go up a stair. So this is a normal size stairwell, and they're just walking up and down, and you can kind of see how close they are to the walls. It's a tight fit without carrying equipment, without moving with urgency, without an emergency smoke and low light conditions. So it kind of frames the issue a little bit. Talked a little bit about infilling sites and the most advantageous location for single exit stair buildings and to increase housing density is in urban areas. So with that, in order to mitigate some of the risk of having a single exit stair, providing other ways to enter and egress a building through ladders or aerial towers is by putting them around the outside of the building. So in the example that Stephen showed, where that building might be closed in on two sides and have the smaller front and back of the building open to a street or an alleyway, that greatly limits the amount of window space and exterior space that the fire department can access to provide secondary or multi-level means of egress. I think perhaps European firefighting operations might rescue somebody down a ladder, but I mean, I'm a firefighter, and if I'm on a ladder, I'm the only one on the ladder because that's how it works. That's how the safety is. Even on an aerial, if I'm supposed to be taking a 300-pound, 6'5" male out of a building, the dynamics of that doesn't really work. And so, when you start thinking about the population that we have in the United States, where people are aging in place, people might have mobility impairments or other kinds of cognitive impairments, whether it's permanent or temporary, rescuing somebody over a ladder or even using an aerial, which is a little bit more stable, is just not feasible from a one-on-one firefighter to occupant ratio there, but also in terms of time. What if there's two people in the apartment? Now, that's going to take a significant amount of time to move somebody down a ladder and then to go back and get another person. So, when we're thinking about codes, that criteria of rescue in that way doesn't necessarily, it's not the best plan. We can probably find something else that's going to mitigate that situation and make it a lot more repeatable and based on data and science, and you can assign a certain amount of time for that. Whereas it's a very fluid situation with fireground operations to try to look at egressing somebody or rescuing somebody. That's the absolute last resort. We want to try to build buildings so that either people can self-evacuate because we've given them enough time, or they're sheltering in place and it's a legitimate, safe situation for them to shelter in place. And we've provided other mitigation means that they're not going to be exposed to smoke and toxic gas while they're in their apartment. So that kind of brings me to some of the other systems that we have in buildings. You've got active systems that need to function, they're in place, and they need to be maintained on a regular basis. And then you have your passive systems that are always there, that are always working, but still need to be maintained over the lifetime of the building. And both of those systems have their challenges. So your smoke detection system needs to be tested. One of the proposals in there was talking about occupant notification. That's a voice evacuation system that actually will help wake people up. It has different frequencies, so it interrupts people's sleep regardless of what their hearing loss might be in an aging generation. Some of those things are going to be more effective than your traditional 3-tone, high-pitched smoke alarm. So there are some things that you can kind of put a better system in a building to offset some of the issues that you would find in a traditional, previously allowed kind of fire alarm system. Sprinklers, there are residential sprinklers and the 13R system. Those are allowed in a lot of these residential buildings, but there are exceptions that they don't need to be provided in concealed spaces or attics or in closets. A full 13 system would provide more coverage, more water supply, and be designed to provide property protection, whereas a 13R system only provides life safety. So there are some things that, while we look at just setting up the building, you can put elements in place that increase the level of safety, but don't necessarily adversely affect the cost to the point that it makes it unrealistic to construct. And so I think, kind of looking at all of this, The issue that we have from the fire service and in some of the engineering community is that, Steve was talking about it, like money talks. And so you have Home Builders Association, American Wood Council, you know, National Fire Sprinkler Association. You have organizations that have a stake in code development and they have the money to do the testing. The fire service generally doesn't. And if they do, they're not organized in a way that the money that they're using for studies and tests are coming through in a meaningful way. The way the fire service gets code change is unfortunately through tragic fatal fires and lessons learned from events that have happened, which is really not a great way to move code forward. So what we've been working on with Code Red and some of our partners and through some of our contacts nationally is to try to stand up some studies to evaluate exactly how wide do you need a stair to be. If you have flow and counterflow in and out of a building, if you have firefighters going up one side and occupants egressing, is that a 48-inch stair? Is it a 60-inch stair? Does it need to be wider than that? Does that even make sense if you can't touch handrails? Like there's probably a magic number in there, but rather than us just throwing a dart at the wall and saying this number's good, we'd like to actually have the data to support it. And then have that conversation looking at better sprinkler systems, better fire alarm systems. Stair pressurization is a great concept. I'll tell you, as a company that goes in and evaluates and does the maintenance and the retesting on these systems, they're never maintained. They always need work. 6 months in after they're installed, something is not working to the day that it was installed correctly, and that's assuming that it was commissioned properly. So the maintenance of systems is a major issue. So potentially if we get single exit buildings, there probably needs to be some type of an inspection schedule with the building department to make sure that they're constantly going through their testing and that their systems are maintained, because those are becoming more critical to the life safety of the occupants in the building as relied upon systems. So I think that we could certainly find a middle ground where a single exit stair building is appropriate, as long as we've really thought about some of the other systems that go in there, active and passive, and the maintenance of long term that can make these systems affordable but still safe. And the concern that I have being in code development for as long as I have, unfortunately, it seems like a lot of decisions get pushed in one direction without as much research as we could be doing to make sure that we understand the entire problem, and making small little changes that can make things a lot better. So that's kind of what I wanted to bring up. I have a lot of things that we can talk about when we get into the questions and kind of expand on that, but I wanted to kind of offer that thought that with intelligent and thoughtful design, we can probably meet a middle ground. But I think I'm excited that there's the potential for a study. It's not very frequent that we do studies on code development. A lot of times it's a little bit of a closed room. It's an open process, but it seems like it's very small group of people make some really impactful decisions. And hopefully if there's a study that Massachusetts can put on that can help inform some of the other states as well and kind of drive the industry towards realizing that there are aspects to this question and this problem that need further research.
Jen, thanks so much. That was great. I'd love to see how we can sign up for that tour a building in fire gear, because I know every time we're working on a building, we're thinking about how small can we make these things. So it would be really interesting to give it a try from the other side for a change.
And you know what? That brings up a great point, just in general. Whenever you're working with a fire department and you have a building that's going into town, if you have one of those kickoff meetings and you can go to the fire station, like a lot of times fire stations are organized to have training props. And so you can kind of go into the stairwell that they use and you can kind of see some of it. It's always a great opportunity to learn more and kind of opens the door to the fact that it's more of a conversation and more of a relationship building opportunity there. So I'd encourage people to always do that.
Nice. Yeah, thank you so much. And thanks again, Stephen. Great presentation. Um, I think so. We had sent around some questions. I'm going to sort of pick from the middle, so to speak, and wondering from both of you, what is your recommendations for the commission? Because it's sort of interesting, and I think we can get into the weeds, and I think we will about the pluses and minuses of each. But to start off, do each of you have a recommendation to the commission that's being set up of things that you'd like to suggest that they be looking at as a way to for them to develop some sense of I think you're both saying there's some consensus here in the middle, and um, what are those ideas? So, Jen, I think I heard from you about more study, but Stephen, what's your thoughts on that?
My thought would be something that is strongly resisted by everyone in the code and fire world, which is to compare the outcomes to single family houses. Um, you know, uh, in Minnesota, the direction of the bill was to compare it to all types, compare single exit buildings to all types of housing. And it was narrowed once the contract was given out and direction was given. No, we just want to compare it to multifamily. And my issue here is that we have two standards in this country, one for single family, one for multifamily. And the ones for multifamily are many times stricter than the ones for single family. And you might say, okay, well, multifamily buildings are at higher risk, but the outcomes are wildly different. I mean, the single family homes are many, many, many more times more dangerous than multifamily. And there's two ways to think about this. One is, well, God, we got to, make our single family houses, we have to impose stricter standards on them to achieve the same level of safety. But another is that people, including, I would say, the vast, vast majority in the code and fire world, have decided that they actually don't want to pursue a zero risk strategy. They actually would prefer to live in a larger house that has a bit higher of a risk. In the code and fire worlds, there's a strong um, they're not happy about the fact that sprinklers are not required in single family houses, and yet how many people in this world install sprinklers in their own single family houses? It's not many. When they make their own sort of personal decisions, there are some. I want to say there are some, especially fire and production engineers that do. Some of them do. Yeah, some of them do it. It's not that common. It's not that common to voluntarily install a sprinkler in your single family home. So I think we also kind of need a broader conversation about risk and what kind of risk we're willing to tolerate. And in this world, we often, we say we can't eliminate risk, and yet we try to eliminate risk. And we don't have any kind of performance-based goal in mind. So, I guess this is really my hesitance is I don't want to pursue a zero risk strategy, and it feels like that's where we head sometimes with multifamily code development. And I think it backfires tremendously. The United States has a high rate of fire death compared to other countries, and it's because the vast majority of people do not live in modern multifamily buildings. They live in older multifamily buildings, older single family houses, or even newer single family houses. And I think another thing is sort of a more holistic look at what the risks actually are, because even if you can completely eliminate the fire risk, the easiest way to eliminate the fire risk, according to the building code, is to simply build a lower rise building. And where do you build a lower rise building? Farther out. How do you get to that lower rise building? You drive. You drive longer, longer, longer. You drive till you qualify, as the mortgage saying goes. And the risk of dying in a car accident in the United States is about 10 times the risk of dying in a fire. And on top of that, you're likely to die at a much younger age. So the actual years of life cut off are many more than 10 times what is cut off in a fire. And we don't balance this at all. I've never heard anybody in the fire code world say, okay, yeah, we can drive this fire risk down, but people are going to be living further and further out, driving more and more. So I would like to balance all of these risks, and that's a much more uncomfortable conversation than like how do we achieve the same risk that we have come to expect in modern multifamily buildings in a single stair building. But I do wonder how far we're going to get in affordability if we accept this massive differential in risk and also never look at any risk beyond the building itself. What happens getting to the building. So that's what I'd like to see.
So you'd like to see the commission look at the amount of risk involved and compare that to other situations? Is that
Other
how you?
occupancies and other dangers of a building, like the danger of getting to the building to begin with. Yeah,
Okay,
I'd like to look at other occupancies and sort of have an honest and open conversation about where Americans live, where they can afford to live, and how we could improve their chance of living in general, not just, if they happen to live in a multifamily building, what is their risk of dying in a fire?
sure. Um, and let me just build on that for a minute, because one of the questions we had was related to the really a lot of the large housing production these days is done with wood frame buildings, the proverbial 4 or 5/2. And I'm wondering what extent is your suggestion limited to building types, as we know it by fire code, which is wood frame versus masonry steel, or
Sure.
is your sense that single stairs can be used for any type of construction?
A more complicated question. I
Hmm.
personally do not like wood frame construction, not just for fire reasons, actually, not even mostly for fire reasons, but I think it's sort of a suburban way of building. I think in a dense city, the sound attenuation of wood frame buildings is poor. I think like it's very difficult to waterproof them, and it brings up issues that architects deal with all the time, which is um, condo defect liability, which has made it very difficult to build condos in this country because you'll just get sued like crazy over leaks eventually. Nevertheless, this is the path that America has chosen to go down. We invest very little in the structure, and we compensate with a lot of active systems. So if you just compare a building in the United States, they're typically built out of wood here, and then they have sprinklers and standpipes and fire alarms. And then abroad, very few buildings have sprinklers. Very few buildings have standpipes. Fire alarms, I'm not sure about, but then the buildings are built out of concrete. That is an incredibly difficult thing to unwind. And I think for fire safety in particular, there are, fire resistance ratings of 30 minutes, 60 minutes, 90 minutes, whatever it may be. I do not see in modern multifamily buildings the assemblies, the wood frame assemblies being compromised in a time that anyone could survive in the building for. I mean, yes, if the building burns for 60 to 90 minutes, the assemblies will be compromised, but I'm not sure anyone's going to still be alive in that building at that time. So when I first made my proposal at the ICC, it was for non-combustible and mass timber types only. Nobody seemed to care very much. In fact, the only person to speak about it was the American Wood Council, which of course was opposed to that idea. So, I live in New York City. We don't allow light wood frame in New York City. The examples that I'm most interested in following are in Europe. They definitely don't allow light wood frame, bigger on mass timber. Nevertheless, the United States has chosen to go down a light wood frame path. I don't like it, but it's here. And so I have, in my proposals, I talk about fire resistance rating, which will often exclude, like certainly type 5B, 3B, I think even 2B. So it's like a material agnostic approach. And I think we are pretty good at encapsulating the light wood frame structure. Um, so anyway, that's my rambling answer is
All right.
taking a material agnostic approach, just looking at the fire resistance rating.
Okay. Thanks for that. And Jen, you want to jump in on the question about the building types or construction types, really?
Yeah, yes, there's a lot to unpack there.
Yeah,
Well,
usually is.
I kind of want to jump into risk a bit because I think that we have consensus codes and we have consensus buildings where, um, as a adult of a certain age, you might have a specific idea of what risk you're willing to take on for yourself, but are you willing to take on that level of risk for your child that lives in the house with you, or your apartment with you, or your elderly, parent that that they have some limitations? Do you want someone else to assume what risk is okay for them? And so when it comes to multifamily buildings, it's the lowest common denominator is really where the risk factor is. Um, when looking at code development, and I think that when you get into the International Residential Code, people can make their own choices because the consequences really affect the occupant of the single family home more so than it affects their neighbor. And so there's a different perception of risk. No one ever thinks anything's going to happen to them. and get in a car and drive to work every day. You never think there's going to be a car accident. But that's the highest payout rate on my life insurance, because it's a high risk to get in a car and drive. But people have kind of accepted it and never assume that it's going to happen to them. So it's an interesting concept to think about that because there are a lot of aspects to it. When you talk about construction, especially urban construction and light wood frame construction, there are a significant number of construction fires having to do with wood frame. And there's developments in NFPA 241, which is the safeguarding during construction code, where it talks about the risks that you are taking on as a developer and an owner. If your building catches on fire, what does that do to the neighborhood? In terms of you have to do a fire exposure risk analysis of if your building's fully engulfed. Are you going to burn your neighbors down? Are you going to impede their egress from their building? How does that work? And that's a newer thing in the code, kind of thinking beyond the property lines, which typically most of our codes deal within the property line, and there's just you put your blinders on and that's all you look at. And so we're talking about infilling some spaces and putting in these riskier construction buildings. Once they're fully encased and they're done and you have your certificate of occupancy and people move in and you have systems in place, the risk goes down significantly. But the consequences of a fire, if the fire moves past the point where it's out of the room, essentially you're past the point of the systems in the building really being efficient. Sprinkler systems are designed to keep the fire within the room of origin, within the area of origin. And once it goes beyond that, there's just not enough pressure in the sprinkler system or water supply to be able to combat the spread of fire. And there's a lot of situations where that's happened. Once that happens, fire department needs to back out of the building for their own life safety, and then the building burns. And so then really what happens to the neighborhood if it's up against other buildings, like what kind of risk are we willing to take on as a community for wood frame buildings to be put into this urban setting where potentially the impacts are going to be greater? And that is all assuming that the building's on fire. Like, hopefully we don't get there. And it gets into risk analysis of like high consequence, low chance, and that whole heat matrix that you can do looking at risk analysis. But I think that certainly non-combustible construction, robust construction, passive systems, fire resistance rated stairs that are non-combustible is definitely a benefit to making sure that the building is more sustainable in the long term. Perhaps it costs more, and we're not really looking at sustainable building materials. But there's a whole conversation about the temporary buildings that are built out of things that can burn, that are going to the idea is that it burns down and you just build a new one. And that's not really a sustainable concept. If you build something out of non-combustible materials, perhaps it lasts longer. It's organized in such a way that it can be reused. There's a whole lot of aspects that come into that problem. I think looking at the research side of things, that whole question of risk and how does that affect people can really snowball into a philosophical conversation about how as a society we look at risk personally and as a whole, which is a whole different genre of professional career. But yeah, in this, it definitely comes in, plays a role. And I think looking at affordability definitely has to be how close you are to public transportation and places of employment is definitely part of that conversation, that there needs to be a better solution. Is moving into the suburban areas, you're requiring people to be of a certain economic status where they can afford a car and they can afford to travel that much and they have that time where going into a job is going to sustain their way of life. So there's definitely some benefit and pros and cons there that should be evaluated to determine what exactly we're looking to accomplish, and are we going to accomplish it by providing these high density single exit stair buildings.
Yeah, nice. Thank you for that. I agree. It's sort of interesting in the question for me, as the legislation works its way through Beacon Hill, is to what extent, how is it framed at the commission level? Because certainly you can open up a whole bunch of things that are well beyond, and I think both of you are pointing to areas that are well beyond the bounds of what a normal commission would be looking at. And I think it's an interesting topic. John, I see where we just hit 9:30. Maybe we should ask for questions from the folks who have gathered here.
Yeah.
We have some others that we can infill, but I think for the moment, why don't we jump in and say if folks have questions, if you can either drop them into the chat or
use
hit
the
your
raise
raise hand
feature.
function. I think that, yes, I've got that.
Um,
And we'll take a few questions from the folks who have gathered.
So I'll be on the lookout for the chat or the raised hand feature. A couple things, if I could. One, and I know Jen or Andy Kohler or Drake Jacobs will absolutely correct me if I'm wrong about this. But I believe I've heard it said a couple times that 1 and 2 family construction does not require sprinklers, which is true. But it is my understanding that the base ICC codes do actually require it. It's just that Massachusetts takes it out. So I just want that to be out there that the national codes do require sprinklering on 1 and 2 family construction. It's just Massachusetts has taken the position for a long time to say, no, not here in Massachusetts. I agree with Jen in the sense of we only learn through tragedy. I see a lot of faces on this call that are old enough, certainly, or have been in practice long enough to remember the West Warwick nightclub fire. And the fact that a fire occurred in Rhode Island, but we changed Massachusetts laws as a result of it, simply proves the point that Jen was making about how we essentially work in reaction to codes. And lastly, on that last topic of type of construction, I find it interesting because we, as AIA, for many years now, have been opposed to a bill filed by Rep. Donahue and Senator Moore multiple times, which essentially would mandate that we build everything out of concrete, out of completely non-combustible construction. And it's something that AIA has opposed for many years for a variety of reasons. But it does bring up the question, at least in this context, of not necessarily do we rethink that position, but should we be rethinking that in the context of single stair or single family home or multifamily home construction of does that make sense? Would it cast in place or concrete make more sense than wood in those instances? I don't know. I'm not going to try to guess. Lastly, I do want to acknowledge that there is a Senate bill, which is the identical language to the House bill we mentioned. The only reason I mentioned the House bill is because the House bill is the bill that is moving at the moment. And that's simply a fact, really more to do with the way the joint rules have been agreed between the House and Senate. On the House side, once a bill has a hearing, the House has 60 days to take action on the bill, whereas the Senate does not have to take action on any bills in a joint committee until December of this year. So that's why there was an extension order on the House bill, which just essentially shows that the topic is alive within the committee and they're still trying to decide what they want to do with it. But with that, I'm going to say Andy Kohler put it in the first question. I'll simply read the question. What do we do if the single egress stair is blocked or filled with smoke? Doesn't that drastically reduce the safety of the firefighters or anyone trying to egress in the emergency? I'll go with Jen first and then Stephen.
Yep, that's a bad situation. So, yeah, that's the crux of the fire service issue with not having the redundancy of a second stair. And a lot of the way that our building codes are put together is with the idea that there is a second option. We limit our common path of travel. We have limitations on our exit access travel distance in buildings. We have a minimum of 2 exits and 2 stairs in most situations. And some of that is based on the occupant load of the building. In terms of how long does it take for people to traverse that exit and get out? The longer that you're in the building, the more time that you're exposed to whatever is happening, and so the risk goes up. So the idea would be, if we're looking at, if you have a and this is the problem with codes, right? So like, you can't necessarily look at the absolute worst case scenario. Not being able to use the stair is the worst case scenario. People are not going to walk through smoke to get out of a building. They just aren't. And if they are, now you potentially have some medical problems with people inhaling hot gas and smoke, becoming incapacitated in the stair, and the problem snowballs. Fire service trying to deal with that situation. Usually the stairwell is kind of a sanctuary where you start your operations and then you move from there. If that's compromised, you can't really do that. So the idea would be to not let the stair fill with smoke. And so you can either evacuate the smoke with a stair pressurization system and pull it out with a fan, which, if that is the case, it's an active system. It needs to be designed appropriately, installed appropriately, commissioned to make sure it works, and then maintained on a regular basis. And anytime you have a human element that's coming into play, there's an opportunity for increased risk. And that one of those steps or a bunch of those steps are not going to happen. So that's the active system. And then the passive system is to have smoke tight, self-closing doors that are going to be fire rated, that are installed correctly in a building that is, limited to the point where you aren't producing enough smoke to go into the stairs. Sprinklers can help to bring a fire down so you have less smoke produced. Your stair closers and all of that should be incorporated so that you're mitigating the risk of even having smoke come into the stair. But again, there's a certain level of associated risk with that approach, that what if it goes into the stair. And I think that's really kind of the crux of the problem, that when we talk about single exit stair buildings, there is no other choice. There's no other option. So how do we fix that? And how can we do that safely? Because a stair pressurization system, ongoing maintenance, heavy, robust construction, at what point do you tip the scales between affordable housing and safe housing? And where are we comfortable compromising between the two objectives? Because you can make an incredibly safe, robust building that costs a ridiculous amount of money. And so now we're not even building them because it's so difficult to accomplish in the code that we're not helping anybody. So that's not a great solution either. So there's some balance in there that I hope that this study takes a look at all of those aspects and really comes up with a solution or a couple solutions or path forward in order to put code provisions in that meet all of those objectives.
Good job. Stephen?
So I think it's important to look at all the risks. So, it's bad if a single stair is blocked by smoke. It's also bad if two stairs are blocked by smoke. That happened in the Bronx in the Twin Parks fire. The building had two stairs. They were both blocked by smoke. It's also bad if a corridor is blocked by smoke. We worry a lot about, moving up and down the building, but the exit access to actually get to the stairway can be very large in the United States. The limit is an occupant load of 500 people, which is 100,000 square feet on a single floor. That corridor does not require any compartmentation with it. It is one large smoke compartment. It can be filled. I'm still waiting for the report, but that may be what happened in the Fall River fire. Given that multiple people died outside of the unit of origin, I'm not sure. So there's a lot of risk of a lot of things being blocked, even in code compliant buildings, and ultimately we need to weigh the risk against the harm. A single stair building in Europe will typically have 12, 24 units at most, sort of in the entire building. It is very common in a new building in the United States for 12 to 24 units to be on a single floor and to be, similarly compromisable. There are ways to evacuate smoke from stairs. There are ways to keep smoke out of stairs, pressurization systems, ventilation systems. In Europe, there's often, even in New York, there's sort of some more passive solutions. The stairway can just simply be outdoors or have some sort of, windows or louvers or something like that. So there's lots of ways to balance risks and also, mitigate it if it happens. And, I'd like to look at all those. I'm always very interested to read the European code sections and to see the systems they have to either keep smoke out of stairs or evacuate them from stairs. I think this topic of smoke control systems and pressurization, it was really disheartening to me to see that there's still little faith in pressurization systems in the United States, and yet they're still required, which raises like either we're requiring something that's not necessary, or we're requiring something that is necessary, but not to the extent that it works. And I would like to see sort of the fire engineering community figure that one out, like which is it? Are there systems, there's standards in Europe that they use for pressurization that seem to have a little more like sort of packaged kits available? Like, would one of those be better than the standard or lack of standard we have here? So anyway, all great questions for a study that I can kind of like give hypotheses about, but ultimately it'd be nice if someone would put some sort of like real money into answering these technical questions.
Thanks, Stephen.
Just quick on the smoke control and the maintenance. I mean, that's the problem, is the maintenance. The system might be designed great. It looks good on paper. But now, with the 10th edition, there's a provision in Chapter 9 that talks about smoke control systems and ongoing maintenance. It's NFPA 4. It's required for high-rise buildings and buildings that have smoke control systems. So if you have an atrium, there's a requirement for ongoing maintenance, but also commissioning during new construction. So we have finally put that in the code and adopted it, and it's good, but it is very disheartening to be out in the field and go test a system that hasn't been maintained and doesn't work, because that's a huge cost to fix that and go back, where if you just put a little effort in, then it would be maintained. But yeah.
Are there also issues during commissioning? Because sometimes I hear people say it's not just the maintenance, it's like they also don't even work on day one very well.
Yes, there are, and it's there's a lot of science and math that goes into a pressurization system. You can't just put a fan at the top of the stair and assume that you're going to pull all of the air out and still be able to open the doors at certain levels, because the pressure differential is very, very vast, right? And so there are ways to set up the systems so that you have graduated levels of pressure and you have a shaft, and you can kind of organize that. But in certain buildings, it's really very difficult to accomplish. Like lab buildings that have exhaust hoods, you can't make the pressure in the building really work. So, in this application where it's a smaller residential building, you have a bit more control over the occupancy and how that space is being used. So a stair pressurization system, and I'm using that term loosely, something that's going to evacuate the smoke out of a stair, that's a great application for it. You don't have a huge height differential, so your difference in pressure isn't going to be, too bad. But it does have to be designed correctly and then tested and make sure that it actually does work. But on smaller applications, it's much easier. Larger applications, it gets a little bit haywire. There's a lot of safety factors that kind of either go one way or the other.
Thank you both. I think everyone on this call, other than Jen and Stephen, would agree. We've all done buildings, and we all know the biggest issue we've ever had is no one ever maintains the buildings. Forget a pressurized stair system, the mechanical systems, the electrical, the plumbing, just in general, buildings are not maintained. So it's a challenge. The next question comes from Doug Rand. I'm going to summarize. Stephen specifically is being asked whether the data comparing fire deaths and multifamily versus single family buildings explains why multifamily buildings have better safety outcomes, specifically whether this difference is mainly due to stricter building code requirements. So Stephen, can you react to that?
I think the answer about anything with fire and data is no. Like, no, we don't have it. I spent a lot of money actually getting NFIRST data, the National Fire Incident Reporting System data, in a database and looking at it. It's really interesting, and I think it could be useful. The reporting is not great. I'm going to call out my local fire department, FDNY. They report 1/4 of all deaths to NFIRST. And so when we did our study trying to look at if there was deaths in single-story buildings in New York, we actually had to go by media accounts. Luckily, New York City has a great media market, and they actually do report on most deaths. So if you can look at the media ones. But unfortunately, even just the basic, like, did someone die in this fire stuff is not recorded very well. And then the details of it are really not recorded very well. I don't know whose fault that is exactly. I know they're redoing the N1st system, but my understanding is generally no, we don't know. There's also fires are fundamentally a very demographic phenomenon. Of a fit, healthy, sober person could probably live in a building made out of gasoline and probably wouldn't die, whereas somebody with a lot of challenges, older, Alzheimer's, mobility impairments, is going to be at risk even in a more code compliant building. So no, the unfortunate fact is we don't. I will say though that multifamily buildings generally have more demographic risk factors than single family buildings. Even new multifamily buildings, I believe, don't quote me on this, you should look at the Pew report, but I believe they found that the income of an average person in a multifamily post 2000 building is actually less than the income of a single family person in a pre 2000 building. And, the poorer you are, but this also, the older, you're at more risk. So that might actually say that the risk differential is actually even greater for, like, if you're comparing like for like. So no, unfortunately, we don't have great data on any of this. I think the start would be keeping better N1st data. If anyone would like to play with the N1st data, I spent a lot of money to get it in a usable format, and I will give it to whoever would like it for free, if anyone's interested. That's my answer.
Thank you, Steve. Jen, do you want to react or have any thoughts to offer?
Yeah, I mean, I think, yeah, N1st is terrible. Well, the problem is that there's only so much information that you can put in, and it takes a lot of time. So, you've got fire departments that are responding to calls all the time, and they need to take time out of their day to put the data in. And generally, firefighters are not like, yay, let's put data in a computer. That's just not their personality type. So, yeah, it's definitely a flawed system. And it's difficult to sort through it and actually get information. We've pulled a lot of records in Massachusetts to try to support code change proposals, and it's been a struggle. And I have like direct contact with the person who puts that data into MFers in Massachusetts. But yeah, no, there's definitely a whole conversation on the demographics of a population that we're looking for these lower income, high density urban population, single exit stair buildings, and the way that people function in a building, like culturally, and just there is definitely some aspect to that I'm not sure is really quantifiable in a data kind of way. But I think we know that family sizes could be bigger, or people could have different ways of associating risk and accepting risk within their own background and their own family structure. That comes into play when we talk about affordable housing and people that need to walk to work or want to be in those areas. There are definitely different demographics between single family suburban homes and the urban settings in terms of the type of people that choose to live there. So, yeah.
Thank you. The next question comes from Deb Crossley. I'll summarize it. She's asking for clarification on how safety record costs between single and multifamily buildings are measured, whether the comparison is based on cost per square foot or per housing unit. And she's seeking clarification on the $230,000 average cost for adding a second stair. Specifically, she's wondering how many stories that estimate covers. So I think this is referring to Stephen's slide earlier on in the presentation.
I got 3 quotes. It was 4 to 6 stories. They were all shockingly close together. I think like 228. It would depend on, obviously the market construction cost will vary widely between Texas and, the Bay Area, but I was a little surprised at how close they all were. But it's the full enclosure, all of the systems, the standpipe, the sprinklers, the electrical, the vertical and horizontal assemblies, and they were 4 to 6 stories. It's very difficult to get quotes down to that granularity because a stair is not built by a single trade and like a single subcontractor who can like give you a quote for it. So like they weren't the best, but given that they all came in at the same amount, I felt sort of confident in it. Would I be surprised if you can build a stair for, $120,000 in Texas, or that it costs $400,000 in San Francisco? No, but that's, I think low 200s is a good average.
Okay.
Mid-rise.
Thank you. Jen, I don't know if you want to react to that or not. It wasn't your slide, so I fully understand you may not have a
No.
comment.
I think Stephen has a lot more information on the data and the cost analysis. So
Sure.
Square
So
foot cost?
the next question comes from Jennifer Smith. She's asking how to reconcile the lower average fitness and mobility levels of Americans compared to populations in places like Europe, Asia, or New York, where people are generally more accustomed to walking and stair use when considering the practicality and safety of single stair buildings in the US context. So I don't know if either of you would like to try to address that or what your thoughts are on that.
I mean, I think that yes, there's a lot of when there's population studies on how people move through buildings and how they interact with buildings, that data is taken from a source, and it takes a while for it to get integrated into codes and performance-based standards. So at this point, the data that we use for modeling from like the handbooks is fairly outdated, and it also has a whole cultural implication to it too. There's fitness of people, but there's also like aging in place. I think our society generally, we have people that are living longer and are independent, that are mobility impaired or have cognitive impairments. And I don't think that our societal system is really, we're not quite as socialist as some of the other countries where people might move into assisted living or a facility that really can handle a lot of that. We have a lot of people that are living on their own due to age or whatever reason. And so I think there's a whole lot of factors that come into play, and even of no fault of their own, you've got like children and stuff that you have to think about as well. And how do they move through a building? Are they going to be slower? There's also like temporary impairments like drinking or whatever the case might be. So yes, that is definitely part of the problem, and part of why I think the zero risk kind of concept is put into the codes, because you can't really guess what people's level of ability is going to be in a building. So you kind of go with the lowest common denominator. And in some cases, if our society was structured a little bit differently, there are some like Sweden and some like Scandinavian countries that have a really good way of handling an aging population with a lot of care and dignity, and they're provided with a lot more resources than what I think we do in the United States in general. So there are definitely differences between European and American approaches to society as a whole, and that does trickle down into how we generate building codes and how we think about what's good for the general population. We kind of rope all that in, and so sometimes it's good, sometimes it's bad.
Thank you, Jen. Stephen?
I would say it is a big issue. Gives me more pause about the current situation and the code compliant buildings than a single stair building. Give you some examples why. So one is that the United States does have a less fit population. It also, though, has a younger population. Europe and Asian countries are aging much more rapidly than we. They have way more elderly people. But secondly, if you struggle with stairs, a single family home in the United States for you is not going to be an amazing place. A single stair could be compromised in a multifamily building. I don't want to discount that possibility. However, it will be compromised in a single family house. There's certainly no code required compartmentation within a single family house. And in practice, those doors are very flimsy and are going to let in a lot of smoke. Finally, the car issue is just dramatically worse. The older you get, a lot of my relatives who grew old in the United States were driving well past when they should have been, sort of stuck in stuck as a dramatic way to put it, but they wanted to live in the, the single family house they always lived in their entire life. And so these considerations come into play, but if you kind of do the balance of it, I'm not sure it speaks that highly to the current situation. And I would be, I'm way more concerned about how people currently live than, living in a single stair building with sprinklers, with, the stairway, really two doors that have some sort of listing between the stairway and your unit. The whole suite of, intense fire alarm systems. I think it's a much safer place, to be honest, than a single family house or an older multifamily building.
Great. Well, thank you. Larry, I don't know it. 5 minutes.
Yeah, I was going to say, it's probably a good place to end, and I'm intrigued by the idea of the demographic question of it, because it really gets to the issue that this is a decision that we as a society get to make, informed by experts on the fire side, informed by experts on the housing cost and viability side. But at the end of the day, it's, to a certain extent, it's a demographic or a democratic decision brought to us by the legislature, which will be interesting. John, maybe with the last few minutes, you could give us a little update. I know you mentioned that it's sort of stuck in process, but what do you anticipate next steps, timing, and is there anything that those who are passionately interested in this topic should be doing to try and push this along?
Excuse me. So what I would say is a couple of things. One, the actual process. So you heard me mention there are new rules that govern the joint legislative committee process. And those rules, as I stated, say that if a bill is filed on the House side and it goes to a joint committee, then the joint committee on the House side has 60 days to take action on the bill after it's been heard, whereas the Senate has until December of this year. So that's where we're at on the bill. The bill had its hearing. There were people clearly that spoke in support of the bill. I don't recall anybody speaking in opposition to the bill. And what is clear by the fact that the Joint Committee, at least on the House side, has asked for an extension, is that they've decided that they're not just going to outright kill the bill. Otherwise, they wouldn't have asked for an extension. But it's also clear that they're not exactly sure what to do with it. If they thought it was something that was needed immediately, they would have reported it out immediately as favorable. So what this sort of indicates to me is that it may get a favorable report. It may get rolled into a larger study that the committee wants to do. I will say my concern about the bill at the moment is the price tag that's attached to it. And anybody that's talked to me about this, I'm not breaking any new ground here by saying that this study has a $250,000 appropriation request to it. And while it would be great to have that money, it is very rare, almost never, quite frankly, that a study that the legislature initiates ever has any money attached to it. I would think that given where we're at today, the House actually is going to be convening today to take up the sub budget. And right now, the Healy administration is facing a statutory checkpoint of today that requires it to revise the state's revenue projections for the remainder of this fiscal year and into next fiscal year. And the early estimates point to about a $3.7 billion shortfall, both short and long-term reductions in the amount of money that is coming into the state, both from the federal government and through state collections, which are reflecting slower economic growth and the declining federal support. I only use that as the backdrop to say a request for $250,000 for a study that, while everyone on this call is going to agree is incredibly important, most members of the legislature are going to scratch their heads a little bit about single stairs. What is this? Why is this important? And why should we care? And more importantly, why would we take $250,000 that could go towards WIC or Head Start or some other program and use that. So in terms of the politics, that's where I see it. We'll know more come December once the Senate has to make its reporting, and we'll certainly know by October 31st whether the committee files for a second extension on the bill or whether they make a reporting on the bill. So hopefully that helps at least with some of the politics on the bill. And I think that's what you asked, Larry.
Yeah, pretty much. John, you're always good to throw a bath of cold water on those of us interested in these topics. So, but that's why we have you looking carefully at what the legislature is doing. But I think, is there anything that you'd suggest folks who are interested should be doing, or is the real message sit tight and we'll see what happens later this fall?
I would say, for those that are really interested in it, the bill right now, it was heard by the Joint Committee on Housing. So I would say if anybody is really, truly interested, it would be get a letter, your own personal letter up to the Joint Committee on Housing stating whatever your position might be. Obviously, I would say check that committee housing membership list to see if your state rep and your state senator are on that committee. If they're not, I would suggest you write the letter to the chairs of the Joint Committee, both House and Senate, and then copy your state legislator and your state senator and your state rep so that they are aware that you are a constituent of theirs and this is an issue of interest to you, and that you've approached the two chairs of the committee. There's not much more else, quite frankly, that can be done on it at this point because it really is in the Joint Committee's hands. And I just want to be clear when I didn't mean to throw cold water on it. I simply meant to say that if I were going to guess if this bill were to move forward, I suspect it will move forward. I suspect the appropriation will be stripped from it, but the base of the language requiring a commission to be put together to look at the topic will likely move forward. I just don't think that the money will be attached to it. I think that would be removed. So slight clarification. Hopefully that's maybe more warm water than cold.
Okay. Thanks, John. And so with that, and noting the time, we should wrap things up. Again, Stephen and Jen, thank you both so much for your time, both this morning as well as getting ourselves organized and prepping for this conversation. I know there are a number of folks who are interested, and hopefully we got some other people interested in the topic. And if anyone does have thoughts, please send them in. We're happy to pass them along.
Yeah.
I just also want to note, Larry, for everybody that we'll put a copy of a recording of this will be up on our website. We'll obviously edit it down to take out the beginning and some of the end, but this will be there. So if anybody wants it, it'll be there.